Hey everyone. I'm going to talk to you about gaining clarity in conversational programmer learning goals. Hey everyone. I'm going to talk to you about gaining clarity in Hey everyone. I'm going to talk to you about gaining clarity in conversational programmer learning goals. So have you ever been teaching in an introductory programming class, maybe particularly for non-majors, and heard something a bit unexpected or strange from your students? Something like, I want to understand what coders are doing, but I don't really want to code myself. Or even, I don't want to know about loops and if else. I want to know in general what programming can do for me. Maybe these students are planning to go into a field like design, management, or marketing. And you might be wondering, with a typical CS1 or even CS0 curriculum, which does have that strong focus on loops, selection, other programming language elements, am I meeting the needs of these students? If you've been in this scenario, you are likely interacting with conversational programmers, a group of programming learners that have been recently profiled in the HCI literature. Unfortunately, research suggests that we aren't meeting these students' needs. Conversational programmers are defined as wanting to understand programming, but not because they want to program, even as end user programmers. Instead, they want to be able to improve their ability to interact with programmers and have better job prospects. These learners present a number of challenges. As people whose primary major isn't computing, they have a relatively short time for computing education. They also tend to have low self-efficacy for programming. And they have a sense of mismatch with typical introductory programming material because it doesn't always meet their needs as they see them, which can result in a feeling of failure. To really address the needs of this group, we realized that one crucial thing that we needed to know was to have a better definition of the learning goals of this particular population. So in this paper, we analyzed the literature to determine what learning goals conversational programmers have. We use theory to explore what knowledge conversational programmers need. And finally, we take some positions and have some recommendations for the question of how we should design instruction for conversational programmers. When identifying learning goals, we use methodology adapted from Rich, Strickland, and Franklin, which has been used in a variety of papers about computer science learning goals in K through 8. First, we performed a literature search for papers that contained the term conversational programmer and those that cited some of those foundational works on conversational programmers. We included publications that had performed original interview or survey studies of conversational programmers, and this resulted in 6 papers, which cover a variety of audiences, including students in multiple majors, professionals in industry, and free-range adult learners. Next, we identified any explicit statement or implicit endorsement of what a conversational programmer can or should be able to do in relation to computer science. So we went through the papers and identified these goals. And so we had this set of goals that was sourced from the conversational programmers themselves. We clustered those goals using commonalities in topics, as well as commonalities in the actions necessary to achieve those goals. And this led to 9 learning goals with 20 subgoals. And here they are. These goals represent a breadth and coverage of all the goals that we extracted. You should check out the paper for details in figure 2, which that figure gives all 9 goals, the 20 subgoals, and representative quotes for each. So let's dig into the goals a little bit. One thing that conversational programmers want to be able to do is be able to recognize what's going on with computational and workplace processes. So this includes sort of understanding how systems are working, being able to recognize terminology, but also understanding how the process of creating programs work. How do software engineers do their jobs? This also includes understanding the use of a product by customers, including when customers are the ones doing programming. Conversational programmers also want to be able to describe code functionality, how pieces of a system work together, what a system can achieve for customers. And something interesting is that they have this desire to translate descriptions from one level to another. So, for example, from the customer-facing perspective to a developer-facing perspective. The next set of learning goals really emphasize, well, goals. Does code meet expectations? And if not, describe the discrepancies in a way that technical team members can understand and act on. Conversational programmers might describe desired functionality, sometimes using a prototype. Conversational programmers also want to know how feasible certain ideas are. They want to know the applications of technologies and the challenges of technologies. Conversational programmers want to be able to gain insight through their own actions, like being able to learn about technology by asking developers directly, or being able to understand documentation. There were some conversational programmers who perform end-user programming tasks, although in a study of conversational programmers at a large software company, only 86% said they programmed more than rarely. The programming tasks that conversational programmers mention are typically end-user programming tasks that help them in their work goals. Conversational programmers sometimes edit code. For example, they might make a simple change in CSS as a designer. And finally, we have non-cognitive goals. Conversational programmers want to form relationships with technical coworkers that support their jobs. And as a part of that, they want to be seen as credible due to their knowledge of programming. They also want to have empathy for what developers go through. They see that as an important part of their role. And finally, conversational programmers' interests are shaped by the job market, with an emphasis on technology that's currently in use in industry. So now that we have all these goals to really inform instruction, the question is, what knowledge about programming do conversational programmers need? What knowledge best supports these learning goals? So to answer this question, we use the structure, behavior, function framework as our theoretical lens. The structure, behavior, function framework is a set of 3 categories of knowledge about designed artifacts or designed things. A program or a software system is certainly a designed thing, so this applies. The first category is the structure. Structure is what the system contains or what it's made of. It's the parts of the system. Next is the behavior. This is how the system works or the mechanisms of the system. The third category is the function, or why the system does what it does. It's the purpose of why the thing was designed. Another important aspect of this framework is that structures, behaviors, and functions are hierarchical. So for example, one component of a system might be made up of smaller subcomponents. Each of those subcomponents is made up of even smaller pieces, and so on. So all that theory is a bit abstract. Let's see how we can apply this framework to a real example and something a conversational programmer might want to understand. Let's say a web chat system for the workplace. So what is this system made of? Well, we could look very small. For example, at the tokens in a line of code. Maybe there's a string variable, a selection statement, and when the code executes, this all matters because it checks if a string is empty. So at this level, we're dealing with syntax and execution, or the notional machine. We can look at larger structures, like a whole line of code, or maybe multiple lines of code that make up a common pattern. Each of these patterns behaves in a certain way that we can describe, and together they achieve a purpose. For instance, code patterns that check if a string is empty and that make a server request could work together to send a message in the chat system. And at this point, you can probably see the hierarchical nature of code structures, behaviors, and functions. So we can keep building up these levels. Let's think in even larger structures, like the database and web interface. These both play important roles that allow the entire system to do what it's intended to do, which is to help people communicate with coworkers. What's so interesting about this application of structure, behavior, and function to code is that we actually find that we have a definition of high level and low level knowledge and what those mean in the context of programming. Lower level involves smaller code structures, higher level involves larger structures. Now, to be a software developer who is writing this web app, you need to understand all of these levels from low to high. But what about conversational programmers who focus so much on the purpose of systems from the perspective of applications and the perspective of users and customers? To achieve most of the goals we talked about, we claim that conversational programmers can focus on the higher levels. They are most connected to the overall purpose of the web app, and therefore most relevant to clients and most relevant to applications. So, what does our analysis and our application of theory tell us about how we should design programming instruction for conversational programmers? The first position that we take is that we need to better define high-level code structures and behaviors. In CS education, we often focus on lower-level code structures and behaviors, and it's not entirely clear how to rigorously describe high-level code structures and behaviors. Maybe this is difficult because they aren't as firmly grounded in the code itself. So to address this, we might look at documentation and conversations to identify high-level code structures and behaviors that conversational programmers use in practice. Second, we believe that scaffolding should allow learners to understand high-level code structures and behaviors without requiring low-level understanding. Remember that this population of learners doesn't have much time. They need to start with what's most relevant for them. Now, this approach is a big difference from our current introductory programming sequences, which start with small programs to allow students to understand all the details and then build up to larger programs. This is going to require new interfaces and supports that those of us in the computing education community should create. Is low-level knowledge not useful to conversational programmers at all? No, but we claim that the focus on instruction about low-level knowledge should be to build empathy for the challenges of programmers, rather than to build mastery of the content. In our analysis of the literature, there were several examples of conversational programmers developing empathy and an understanding of just how difficult it can be to write or modify code through typical CS1 tasks. But deep mastery isn't necessary to meet that goal of empathy for programmers' challenges. So in sum, we are starting the conversation on conversational programmers in the CS education community. This is a really interesting user group that really tests our assumptions about what we should be teaching and when. We're looking forward to the future designs that will meet the needs of conversational programmers, and we hope that this paper will help us get there. I want to give a big thank you to my amazing co-authors, including two fantastic undergraduate researchers. I also want to thank Mark Gusdile and Barbara Erickson for their formative discussions on this topic during my PhD. And I want to thank the Delta Lab for their feedback that improved this paper. Thank you.